In this section, we will solve a system of equations that has three linear equations. So for example, here is a system of equations which has three linear equations and three variables. So if there are three variables, then we need three equations to solve that system. And finally, once we solve this equation, we will finally have row echelon form. The row echelon form is, the bottom is the z value, equation of z value. The second equation contains the variables y and z, and the first equation contains all three variables x, y, z. So this is what we want. The final system should be like this. Okay, so in order to make a row echelon form, okay, there are three definitions, three operations that we can consider. Okay, the equivalent equations, equivalent system. So I'm going to write another system that is equivalent to the original, and this system will remove the x terms, okay, two x terms in the second and the third row. Okay, so one of the operations to do this is, okay, we can interchange equations. There are three equations, 1, 2, 3. So we can interchange all these three as you want. The best one is the first equation. If the first equation starts with x, the coefficient of x is 1, then that is the best position of that equation. Okay, number 2, we can multiply the first equation by some number to get rid of the x term in the second and the third. So we can multiply the first equation, and then what we can do is we can add the first equation to the second equation so that we can eliminate this x term. Okay, let's try. Let's see what happens here. Okay, the first equation stays the same. And for the second equation, I will remove this negative x. Remove the negative x by adding the first equation to the second equation. So I will add the first equation to the second equation. So first equation plus the second equation. Then x minus x is 0. We don't write 0. Just leave it blank. Negative 2y plus 3y is just y. And 2z plus 0 is 2z. The right side of the equation is 9 minus 4 is 5. So we have second equation, y plus 2z equals 5. And the second equation has no x term. Okay, the third term also, we will remove this 2x. Remove this 2x from the third equation. I will use the first equation to remove 2x in the third equation. In order to move this one, eliminate this 2x, we will multiply the first equation by negative 2. So I will multiply the first equation by negative 2 and then add it to the third equation. Okay. So negative 2x minus 2x is 0. So leave it blank. The first equation, negative 2y times 2, negative 2 is negative 4y, positive 4y, and then add it to the third equation, which is negative 5y, then this is negative y. Okay, for the z term, okay, positive 2z times negative 2 is negative 4z. Negative 4z, add it to the third equation, z, then that is negative 3z. Okay, 9 times negative 2 is negative 18. Negative 18, add it to the third equation, which is 10. Then is negative 8. Okay, so we have another system of three linear equations. And this is equivalent to the first system. So from this system of equations, we have eliminated x terms from the second equation and third equation. Okay, so finally, the last two equation has two variables. We learned this one in earlier chapter to solve y or z. We can do the same thing here. From the let's write the third system of equations. Okay, the first one, we don't have to change anything. We will use the second equation and third equation to eliminate the y term from the third equation. So the second equation stays the same. What we can do is add the second equation to the third equation. Then y minus y is 0, leave it blank. 2 minus 3 is negative z equals negative 3. Okay, so we have third system of equations, which is same as equivalent to the second system. Okay, now in order to write this in row echelon form, okay, let's multiply the third equation by negative. Okay, the first equation and the second equation are the same. Then the third equation, z equals 3. All right, so this is the system of equations which is equivalent to the original equation. Okay, then once we have row echelon form, already z value is found. We found the z value, and then we can find y value from the second equation. So from the second equation, let's plug in the z value. So y plus 2 times z equals 5. Y plus 5 is equal to y plus 6 equals 5. Then y equals negative 6 each side, then the y value is negative 1. Okay, now we found y value, z value, then use the first equation to find the x value, so that we can plug in the y and z values. Okay, x minus 2 times y plus 2 times z. Z is 3 equals 9. Then x minus x plus 2 plus 6 equals 9. X plus 8 equals 9. Then x equals minus 8, each side 1. So we found all values of x, y, z. So the solution is x equals 1, y equals negative 1, and z is 3. So we have this ordered triple. So there are 3 values. We call it ordered triple. This was an example 1 and 2. And this is important. Okay, the operations to make equivalent systems is we can interchange 2 rows in the system. We can, and then we have to multiply. We have to eliminate one of these 3 variables. So it is best to eliminate x term. So using the first equation, multiply any number that is necessary to eliminate x term in the second equation and third equation. And then, so multiply the first equation by some number to eliminate x term. And then add it to the second equation so that we can eliminate this x term. Multiply the first equation by some number to eliminate this x term from the third equation. So what we have to do is multiply the first equation by some number, add it to the third equation, and the result will be the third equation that does not contain the x term. Okay, let's try another example. Okay, this is example 3. Okay, in order to solve this system of equations, okay, let's interchange the first row, first equation, and the third equation. Because the third equation starts with x, the coefficient of x is 1. And the best one is if an equation starts with x with the coefficient 1, that's the best one to be placed in the first equation. So I will interchange these two equations. So the third equation becomes the first one. And the second equation stays the same. Negative 3y. Okay, now the third equation comes from the first. So interchanging the equation is still equivalent to the original. Okay, so we have here's first equation, now second equation and third equation. Okay, I will use the first equation to remove 2x from the second equation. Also, I will use the first equation to remove 4x from the third equation. So first equation stays the same. Okay, I'm going to write system of equations that contains 3 equations. So the second equation will be this. I will multiply the first equation by -2 so that the coefficient of x will be -2. So -2x minus 2y minus 2z equals +6. And then I will add this equation to the second equation. The second equation is 2x minus 3y plus 2z equals 9. So multiply the first equation by some number, and that number is the opposite of the coefficient of x in the second equation. And then add the multiplied equation to the second equation. Then cancel out the x term. The y term is -5y, and z term cancel out, and this is equal to 15. So write this one in the second equation. -5y equals 15. Okay, for the third equation, I will remove this 4x. So what we can do is multiply the first equation. Multiply the first equation by -4, then -4x, -4y, -4z equals 12, and add it to the second equation. I'm sorry, the third equation. The third equation is 4x plus y minus 3z equals 11. Then cancel out the x terms. -3y minus 7z equals 23. So the third equation is -3y minus 7z equals 23. Okay, so as you can see here, the first equation has not been changed, but we changed the second equation and third equation by eliminating that x terms. Okay, from here, the second equation and third equation has 2 variables, y variable and z variable. From this, we can, if you see this, the second equation, if you see this, the second equation is divisible by -5. So why don't we divide the second equation by -5? So the first equation is unchanged. Second equation, divide the second equation by -5. Then y equals 3. The third equation stays the same. Okay. So we have another equivalent system of equations. Okay, then from here, from the second equation and third equation, let's get rid of the y term from the third equation. So in order to write this system of equation in row echelon form, the third equation must have z equals something. So we have to eliminate this y variable with what? By using the second equation. Okay, don't use the first equation. The purpose of the first equation is to eliminate x term and the y term from the second and third equation. So since we eliminate these two x terms from the second and third equation, we will use the second and third to eliminate the y term from the third equation. Okay, so to eliminate the y term from the third equation, what we can do is, okay, first write the first and second equation without any changes. Now the third equation, okay, what we can do is the coefficient of y is -3. Y is -3. So multiply the second equation by +3. +3, then that is 3y is equal to 9. And then add this result to the third equation, which is -3y minus 7z equals 23. Then y cancel out, -7z equals 32. 32, is that correct? Okay, one moment. I think something's wrong. Okay, here is a mistake. From this second equation, when we divide the second equation by -5, then it is -3. So this should be -3. So this should be -3. Okay, so we gotta multiply the second equation by 3. Then this is -3. And then add this equation to the third equation. Then -7z is equal to 14. Then you can write z equals, divide each side by -7, then -2. So you can write it z equals -2. So we have a system of equations which is equivalent to the original, that is written in row echelon form. So the last equation is the z value. The second equation is the y value. There is no z value in the second equation. We have the y value directly. Then we can find the x value from the first equation. So x plus y is -3, and z equals -2, -3. Then x minus 5 equals -3. So x equals +5 each side, x equals 2. So the solution for the system of equation is x is 2, y is -3, z is -2. So this is the solution of this equation. Okay, this is an exercise number 11 on page 186. Okay, from here, first we don't have to interchange equations because the first equation, the coefficient of x is 1, so just we don't have to interchange. So using the first equation, we will eliminate 3x and 5x. So let's write the second system. Okay, first equation is unchanged. We will just use the second equation and then change the second equation. Okay, in order to get rid of this 3x, multiply the first equation. Multiply the first equation by -3. And then add this result to the second equation to replace the second equation. Then -3x minus 18y minus 6z equals -27. Okay, and then add this one to the second equation. The second equation is 3x minus 2y plus 3z equals -1. Okay, so first of all, multiply the first equation by -3. The reason that we multiply -3 is to eliminate 3x from the second equation. So add these two equations, cancel out the x terms, then -20y minus 3z equals -28. So this is the second equation. So we can rewrite the second equation as negative 20y minus 3z equals negative 28. All right, so we eliminated 3x from the second equation. And now let's eliminate 5x from the third equation. So the coefficient, since the coefficient of x is 5, let's make the coefficient of x in the first equation to negative 5. So multiply the first equation by negative 5 and add this one to the third equation. So first equation by negative 5 is negative 5x minus 30y minus 10z equals 9 times negative 5 is negative 45. So add this result to the second equation. No, sorry, the third equation. 5x minus 5y plus 2z equals 7. So add these two equations, cancel out the x terms, and negative 35y minus 8z is equal to negative 38. So this equation is now the new third equation. So negative 35y minus 8z is equal to negative 38. So we have first equation, second equation, and third equation. We eliminated x terms from the second and third equation. So we have y and z terms in the second and third equation. So from here, let's eliminate the third equation, the negative 35y from the third equation. So first equation, you can just write the first and second equation without changing anything, because we just want to eliminate this y term from the third equation. So okay, so as we can see these two equations, okay, what's the LCD? What is the LCM? What's the LCM of the coefficient of y? Negative 20 and negative 35. The LCM is the common multiple. The smallest common multiple is, okay, let's try from 35. Multiple of 35 is 35, 70, 105, and 140, and so on. Okay, let's check each multiple of 35 whether it is a multiple of 20. Okay, 35 is not a multiple of 20, 70 is not a multiple of 20, even 103. But 140 is a multiple of both 20 and 35. So the LCM is 140. Okay, so let's make the coefficient of y and coefficient of y in the second and third equation to be 140. So why don't we multiply the second equation by negative 7. By negative 7, then it will be 140. So multiply the second equation by negative 7, then 140y plus multiply 7 times 3 is 21z equals negative 28 times 7. That is 196. Okay, and the third equation, okay, multiply the third equation by this time 4. So 35, negative 35 times 4 is 140. So that's negative 140. So multiply the third equation by 4, then negative 140y minus 8 times 4 is 32z, and negative 38 times 4 is negative 152. Okay, so that is equal to, so add these two results, two equations, then cancel out the y term, and z is negative 11z is equal to 44. Now z equals negative 1, negative 4. Divide each side by negative 11, so negative 4. So the third equation is z equals negative 4. This is the row echelon form. The last equation is z equals something, which gives you the z value. And let's find the y value from the second equation, and then find the x value from the first equation. So from the second equation, negative 20y minus 3 times z is negative 4, negative 28. Then negative 20y plus 12 equals negative 28. Then negative 20y equals minus 12 each side. Then negative 40. So y equals 2. So we found the y value. So the z value is negative 4, y value is 2. And let's find the x value from this first equation. And this was the second equation, this is the third equation. Okay, the first equation is, okay, from the first equation, x plus 6 times y. Y is 2, plus 2 times z. Z is negative 4, equals 9. Then x plus 12 minus 8 equals 9. Then x plus 4 equals 9, minus 4 each side, then x equals 5. So we found the y value, the x value. So the solution to this system of equation is x is 5, y is 2, z equals negative 4. This is the solution. This order triple is the solution. Okay, let's check how we got this solution. Okay, this is important. Okay, interchange two equations so that the first equation starts with x. That's the best one. If there's no x term, then if the coefficient of x is not 1, then that is okay. You can use any equations to be on the first equation. Okay, then make sure to use the first equation. Always use the first equation. If necessary, multiply the first equation by some number which is not a non-zero number. With the result will be the coefficient of x should be the opposite of the coefficient of x in the second equation. So in this case, we gotta multiply the first equation by negative 3 so that we can eliminate this 3x from the second. So multiply the first equation by some number, in this case negative 3, add it to the second equation, then the result is the second equation. It's the second equation, it comes over here. Okay, using the same method, use the first equation to eliminate 5x from the third equation. In this case, multiply the first equation by negative 5 so that we can eliminate this 5x. So multiply the first equation by negative 5, add it to the third equation, then the result is the third equation. Then finally, the second and third equation has variables y and z only. Then we can solve for y and z from this one using the previous section. Okay, by the way, using the second equation, in this case we have to write same coefficient of y. So we have to find the LCM of 20 and 35. LCM of 20 and 35, which is 140. So we will make the coefficient of y to be 140. The other one is negative 140. So when we add these two, the y terms are eliminated. Okay, this is how we do this one. And let's do another example. And this example, we will use the same method. So let's try another example. Okay, this example is a system of equations that has no solution. Okay, let's use the same methods to write an equivalent system in row echelon form. Okay, the first equation starts with x, that's the best one, so just leave the first equation. And using the first equation, we will eliminate 2x. So the first equation is unchanged. Okay, let's write the second equation. So multiply the first equation by -2 because the coefficient of x in the second is 2. So 2x, -2x plus 6y minus 2z equals -2. And then add this to the second equation, which is 2x minus y minus 2z equals 2. Then cancel out the x term, 5y minus 4z equals 0. So this is the second equation. So write the second equation. Okay, so the second equation has no x term because we just eliminate the x term. Okay, now let's write the third equation by eliminating this x term. So first multiply the first equation by negative, then -x plus 3y minus z equals -1. Why do you multiply -1? Because the coefficient of x in the third equation is 1. So let's make the coefficient of x in the first equation to be -1. So multiply the first equation by negative. Then add this result to the third equation. The third equation, x plus 2y minus 3z equals -1. Cancel out the x term. Then 5y minus 4z is equal to -2. So this is the third equation. 5y minus 4z equals -2. So first equation, second and the third equation does not have x term. It has only, the second and third equations have only the terms y and z. So from here, let's get rid of this 5y using the second equation. Since the coefficients are the same, coefficients of y are the same, so why don't we multiply the first equation by -1 and add it to the third equation. So -5y plus 4z equals 0. 0 times negative is 0. And the third equation is 5y minus 4z is equal to -2. Add these two, then cancel out the y terms. Z terms cancelled out, then -2. So this is the third equation. And as you can see, the third equation is okay, let me rewrite the third system of equations. The x minus 3y plus z equals 1. Second equation is 5y minus 4z equals 0. And the third equation, this third equation, we try to eliminate 5y from the third equation. And the result is 0 equals -2. 0 equals -2. Do you remember that if an equation has, if an equation is false, then there is no solution. So we can conclude that since the z value, z value does not exist, and the equation for z is false, so we will say that there is no solution. We don't have to find y and x because we don't know what the z value is. So there is no solution for this system of linear equation. Okay, what if we have, let's say, if the last equation is 1 equals 1 or 3 equals 3, which is true. And then the result is there are infinitely many solutions. Infinitely many solutions. So when you solve system of equations, the type of solutions are there are three types of solutions. One is there is an exact solution, and the second is there is no solution, just like in this example. And the third one is there are infinitely many solutions. So let's try next example that contains infinitely many solutions. Okay, this example is the case that the system of three linear equations has infinitely many solutions. Okay, let's try our this example using the same method. Okay, first of all, the x term in the second equation is eliminated, so we don't have to eliminate this part. And the third equation is negative x. So let's use the first equation to eliminate negative x from the third equation. So the first equation is unchanged. Second equation, already x term is removed. Okay, for the third equation, why don't we just add the first equation to the third equation? Then x minus x is 0, so leave it blank. Y plus 2y is 3y. Negative 3z plus nothing is negative 3z equals negative 1 plus 1 is 0. So first equation, this is second equation, and this is the third equation. So using the second equation and the third equation, let's eliminate. Using the second equation, let's eliminate 3y from the third equation. So why don't we multiply the first equation by negative 3 so that the coefficient of y is negative 3. So negative 3y plus 3z equals 0 times negative 3 is 0. And the third equation is 3y minus 3z is equal to 0. Add these two equations, cancel out the y term, cancel out the z terms. So 0 equals 0. The third equation is 0 equals 0. So let me write the system of equations. The second term is this. And the third term is 0 equals 0. 0 equals 0. The third term is the equation for z value. So which means 0 times z equals 0. Then z can be, there are infinitely many numbers for z. And the third equation is true. So we can conclude that there are infinitely many solutions. Infinitely many solutions. Okay. In this case, since there are infinitely many solutions, then what is the type of the ordered pair, the solution? Okay, let's say z. Okay, let's say z can be any real number. Z can be any real number. So why don't we set the z value is some number a, some variable a, and a is a real number. A is a real number. Okay, so z is a number a, any real number. So let me write a solution. There are infinitely many solutions, but let me write the type of the solutions. So the z value, let's say z value is a. Then what would be the y value? Okay, from the second equation. Okay, first equation, second equation. From the second equation, let's write y in terms of a. So y minus z, and z equals a. Then y equals positive a. Okay, move this one to the right. So the format of y is a. Okay, how about the x? What's the format of x? What's the type of x? X value. So we can use the first equation to write x in terms of a. So x plus y, y is a, minus 3 times z, and z is also a, that equals negative 1. Then x minus 2a equals negative 1. Then x equals, move negative 2a to the other side, then 2a minus 1. So x can be written as 2a minus 1. So we can write an ordered pair, even there is there are infinitely many solutions. The order pair, the infinitely many solutions, the solution type looks like this. Now, this A is a real number, any real number, so you can use if A equals 0, then there's another pair, there's a pair of solution, order triple of a solution. If A equals 1, there's another order pair of solution. If A equals 2, another order pair of solutions. So there are infinitely many solutions. So whenever the result, the third equation is true, then the system of equation has infinitely many solutions, and you can assume that A is a real number for z value. Then you can find x and y in terms of A.